Section 4.3 we're going to do today. This is a review of what you guys have already learned in geometry. It's going to tie in some of the stuff that we did in 4.2, and it's going to bring us into 4.4. So your test on Thursday is going to be over what we did on the quiz, 4.1, 4.2. I'll give those back to you, if not tomorrow, definitely Wednesday. And then, because I have 19 makeups. And then you'll have this in addition to. So should be pretty self-explanatory, pretty straightforward. We are going to do word problems. So tomorrow, the whole class period, we're just working on just word problems. So this is going to be a review today, and then word problems for tomorrow. Check your calculators right now. You need to be in degrees, all right? If you have, there's a mode button on your calculator. If you don't know where it is, I'll show you. But you need to be in degrees. The first part of this, you guys have to do with exact values. See where it says DEG? Exact values, which means you'll have a square root in your answer. And then the last few, when we do our word problems, you'll have to be in, hold on a second. Yeah, you're good. You'll have to make sure that your calculator is in degrees, or else you'll see what happens when it's not. You get the wrong answers. But when we talk about right triangle trig, all right, you guys are all familiar with right triangle trig. What is that theorem that we know to find out either a missing leg or a missing hypotenuse for right triangle? Pythagorean theorem. A squared plus B squared equals C squared, right? Where A and B are the legs, and then C is your hypotenuse. What do we know about the hypotenuse? It's the longest side, and it's always across from the right angle, right? Everybody got that? Across from right angle. All right, these are my legs. This is a leg, and your hypotenuse. Side, right? It's the longest side, yep, and it's always across the right angle. So we're going to talk today about angles that are in the first quadrant. That means everything is positive. But if you guys remember stuff that we talked about in the last period, not last period, but last class, last week. All right, we had a right triangle, and this was our theta. It was always at the origin, right? That's where I want you guys to be thinking now. We're going to be thinking always from the origin. This left to right value is our x. What does x go with? If you have an ordered pair, what's your x value, the sine or cosine? Cosine, okay. The up and down, the height of your triangle is your y value, right? That's your sine. Agreed? Okay. And then this is your r value. In this case, it's going to be our hypotenuse. So in our next section, we're going to use this formula. X squared plus y squared equals r squared. What is that the same formula? It's the Pythagorean theorem. It's just using different letters. X and y are your legs, and r is going to be your hypotenuse. But your x and your y value is not going to be given to you in a picture. It's going to be given to you as like a coordinate or in a trig function. And you have to determine the x is the left and right, the y is the up and down, and that sort of thing. But what we're going to talk about today is just our basic right triangle trig, given a triangle and that sort of a thing. We are talking today about only stuff that the angle lies in the first quadrant, meaning your x and y values are positive. Okay, so if we have sine, cosine, tangent, you guys are familiar with SOHCAHTOA, correct? SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. TOA is opposite over adjacent. So if you think about this, guys, how would you find your tangent? You would take the opposite y value over the x value, correct? It all relates to what you learned back in the day when you were just given a triangle and did SOHCAHTOA. This is the exact same thing. We're just going to practice it today, and then we're going to bring it into practice in 4.4. So if you have your cosecant, if sine is opposite over hypotenuse, what is cosecant? Hypotenuse over opposite. We're just going to flip it. So what is your secant? Hypotenuse over what? Adjacent. And then what's your cotangent? Adjacent over opposite, right? We're just flipping it. Everybody agree? Okay. We just talked about that. Everything that I just said, you guys just talked about. All right, if you have to give the abbreviations, if this is a question on WebAssign, here's the abbreviations. Tells you what the opposite side is, what the adjacent side is, all that good stuff. So in a case like this, if you're asked to find all 6 trig functions, and it says exact value, that means don't use your calculator. What are the 2 pieces of information you know?
The X and the Y.
You know the x and the y. You know the opposite and the adjacent. What are you looking for? The hypotenuse. So how would we figure out what that missing side is? 3 squared plus 4 squared equals your hypotenuse squared, right? I'll use C or R. Doesn't matter. So 9 plus 16 equals C squared. So 25 equals C squared. When you take the square root, what does your hypotenuse equal? 5. Why isn't it plus or minus 5? Because there's no negative length. Good. All right, so this is going to be my suggestion to you guys, just so we don't make silly mistakes. Here is your theta. This is the angle that we're referencing. In regards to theta, what is the opposite side? What value? Okay, so I write down opposite is 4. What is the adjacent side? The adjacent side is 3. And what is the hypotenuse? 5. Now, to find all of the trig functions, this is the only bit of information you need. Sometimes that's helpful to where we don't make a mistake when we look back up at the triangle and if you label the sides and you just write it out like that, it's really hard to make a mistake. Meaning, when you get to this point, what did we say the opposite side was? Okay, opposite's 4, adjacent is 3, and hypotenuse is 5. So look how easy we can do this. Sine is what over what? Opposite over hypotenuse, which gives me what? 4 over 5. So what is my cosecant? 5 over 4. Flip it. All right, so cosine is adjacent over hypotenuse. Well, what is that going to give me? 3 over 5. Good. So what is your secant? 5 over 3. Okay. Tangent is opposite over adjacent. 4 over 3. So cotangent is 3/4. All right. I think it's best to do that. When you're given a triangle, figure out what all the sides are, and then just write it in a little list, and then it's really easy to see right in front of your face. So the first couple problems, this is all we're doing. You're just going to have a picture, right? Here's a picture, and you're going to tell me all the trig functions. So I'm going to label both stuff in the triangle, and then I'm only going to do one of them because it's redundant. But first of all, go ahead and change this 10. Just change it to a 12. Because the hypotenuse has to be the longest side. But looking at both of these, you don't have to use the Pythagorean theorem because they already told you what's what. So if I'm looking here in example 1, here is my theta. In regards to theta, what is 5? Okay, so the opposite is 5. What is 2? Adjacent is 2. And what is the square root of 6? The hypotenuse. What is the square root of 6 in your calculator? Okay, that doesn't make sense then. Hang on. Make this the square root of 14. Okay, let's change this. Let's change this to the square root of 6 and change this to 5. This 5 needs to be the longest side, right? Agreed? All right, so our opposite side is going to be the square root of 6, and then our hypotenuse is going to be 5. So mathematically, it makes sense. So if you're going to find all 6 trig functions, and it says exact value, that means no decimals. So what is your sign? Opposite over hypotenuse, yeah? So what's the opposite? Square root of 6 over 5. Perfect, okay? What can I do now? I know the sign. What can I now do real quick? The cosecant. What's my cosecant? 5 over square root of 6. Well, what's the problem there? You got to rationalize, right? You cannot have a square root in the denominator, so we're going to rationalize. This becomes 5 root 6 over 6. When they say exact value, that means you're going to have a radical. So what's our cosine? Cosine is adjacent over hypotenuse. What's your adjacent side? 2 over 5. Okay, so if I know my cosine, I can also do secant. What is it going to be? 5 over 2. Perfect. All right, tangent is opposite over adjacent. Well, what's your opposite side? square root 6 over 2. Perfect. So if I know my tangent, then I can go, my cotangent is 2 over square root of 6, which I cannot leave. So this becomes 2 root 6 over what? 6. Can I simplify? Yep. What goes into both 2 and 6? 2. So this becomes square root of 6 over 3. Perfect. All right. Super basic from what you guys have done before. I'll do the next one. I'll start it off and then you can finish it if you want to. So again, look where theta is. In this case, theta is located up here. So in regards to theta, what is the opposite side? What is the adjacent side? And what's the hypotenuse? Remember, the hypotenuse is always the longest side across from the right angle. So if you want to say that one first, what is it? Hypotenuse is 12. All right, so what is 11? Opposite, good. And adjacent is square root of 5. It's right next door. So sine, again, is opposite over hypotenuse. What's my opposite side? 11 over 12. Okay, so if I know my sine is 11 over 12, what is my cosecant? 12 over 11. Just flip it. Good. Cosine, adjacent over hypotenuse. What's the adjacent side? Square root of 5 over my hypotenuse is 12. So then what's my secant? 12 over square root of 5, which we don't like. So square root of 5, square root of 5. So this becomes 12 root 5 over 5. Can you simplify it all? No? Okay, perfect. And then tangent's what? Opposite over adjacent. So 11 over the square root of 5. No bueno, right? So 11 root 5 over 5. So if my tangent's 11 over square root of 5, what's my cotangent? Square root 5 over 11. All right? You guys okay with that? Super basic. We're good? All right. So this brings us into problems. Again, everything's in the first quadrant. Everything's positive. This is going to bring us into section 4.4. Sometimes you're not going to be given the triangle. You're going to have to figure out everything just by what is given to you. So when I look at this, it says the cosine of theta is 5 over 8. Okay, well, I'm going to draw a triangle. And then I also want you guys to identify, because this is a right triangle, I want you to identify what we're talking about. I always draw my right triangles in this position because I like to think of it as it's always coming from the origin, because that's where we're going to be starting from. That's where our brain should be thinking. So when I'm given the cosine is 5 over 8, you guys can tell me the opposite sides, the adjacent side, and the hypotenuse. That's what you need to figure out given that information. So what was given to you with 5 over 8? Adjacent and hypotenuse. So the adjacent side is 5, the hypotenuse is 8. What am I looking for? I'm looking for the opposite. Label your triangle. My adjacent side, that's next to theta, is 5. My hypotenuse is 8. I'm looking for this leg. Right? I'm looking for this value here. You can make it any letter you want, but I'm looking for the leg. How do I do that, given the information? Okay, so y squared, a squared, b squared, whatever. Y squared plus 5 squared equals 8 squared. So y squared plus 25 equals 64. So if I subtract 64 minus 25, what do I get? 39. And then what? Take the square root. So y equals the square root of 39. So you know that this is now the square root of 39. So square root 39. And then look, what can you do now? You can find all 6 trig functions, right? Just by giving the value of one trig function, you can find all of the other information. You just have to know how to problem solve to get through that. So I'll do this whole one here, and then we'll move on. Again, to find all 6 trig functions, you would do opposite over adjacent, that sort of thing. But given cotangent, okay, I'm going to draw my triangle. Here's my theta. What did they give me with the cotangent being 7? First of all, if it's a whole number, I know it's over what? Okay, they gave me 2 numerical values. What is cotangent the reciprocal of? Tangent? Okay, so tangent, guys, is opposite over adjacent. So what did cotangent give me? Adjacent over opposite. Okay, so I know my opposite side is 1. My adjacent side is 7, and my hypotenuse is, I don't know. So my opposite side is 1, my adjacent side is 7, I'm going to find the hypotenuse. So I have 2 legs, I'm looking for the longest side, yeah? So 1 squared plus 7 squared equals c squared. 1 plus 49 equals c squared. So 50 equals c squared. Take the square root. C equals. Can you break down 50? Perfect square and a non-perfect square? 25 times 2. So your hypotenuse is 5 root 2. If you can break down, you absolutely have to. Again, exact value. You have to break down and you have to leave as a radical. So this is the only information you need. They gave us one trig function, one value. We found out what the length of all 3 sides were, and now we can find the other trig identity. So the sine of this angle, well, sine is opposite over hypotenuse. What's my opposite side? 1 over my hypotenuse is 5 root 2. So now you guys are like, oh, I have a radical in the denominator, but there's a 5 with it. Guys, don't worry about the whole number that's out in front. When you rationalize, you can multiply by everything, but you only have to use the radical. So when I multiply here, I get 1 times square root of 2 is the square root of 2. Then I have 5 times, well, what's the square root of 2 times the square root of 2? 2. So this becomes the square root of 2 over what? 10. Can I simplify that anymore? No. If it was 2 over 10, yes. If it was the square root of 2 over the square root of 10, yes. But since one is inside of a square root, one is on the outside, you cannot. So if I were to ask you now for the reciprocal is your cosecant, you can go ahead and take this and flip it. Or you can go at the beginning and say, well, cosecant is hypotenuse, which is 5 root 2, over opposite 1. There you go. But understand, if you have a radical in the denominator, you have to rationalize. You've got to get it out of there. You could multiply top and bottom by 5 square root of 2. That would be fine. It just makes your simplifying at the end a little longer. Like if I had 1 over 5 square root of 2, and I multiplied the top and bottom by 5 square root of 2, you could definitely do that. So this becomes 5 square root of 2 over, well, 5 times 5 is 25, right? Times square root of 2 times square root of 2 is 2. So then you have 5 square root of 2 over 50. And then when you simplify, this becomes square root of 2 over 10, which is what we got right there. So you can do it. You just have to remember to simplify more at the end. Everybody okay with that? Okay. So this chart, right, it is helpful if you guys know these off the top of your head. But again, you're going to be given the unit circle. So you don't have to necessarily memorize this. But I want you guys to understand sine of 30 and pi over 6. Pi over 6 and 30 degrees are the same if you were to convert them. But I want you guys to think about something. From what we talked about last week, right? Anything that's on the unit circle, you could take the ordered pair and you could tell me what the sine and cosine are. So what is at 30 degrees or pi over 6, what's the y value of this ordered pair? What's the y value of this ordered pair? Well, we didn't do so great on our quiz if we can't answer this question. What is sine? What value is sine? X or y? X. Which one? Y. Okay, so at 30 degrees or pi over 6, your y value is 1/2. What is your cosine? Square root of 3 over 2. Well, how did they come up with the tangent being root 3 over 3? They divided the y over the x, right? So at 45, what are your x and y values? Square root of 2 over 2. And then how do you get your tangent? Well, you just divide them. You get 1. If you guys notice, you guys are familiar with 45, 45, 90 triangles and 30, 60, 90. This all comes from the unit circle. So that's just kind of neat to see. All right, now we're going to start talking about word problems. I'm going to do a couple with you now, and then we're going to do all word problems tomorrow in class. That's all we're going to do is just work on word problems, because the math behind this is super easy, but where to put the information can get a little confusing. All right, so when we talk about angle of elevation and depression, if you think about elevation, I think of the word up. When I think about depression, I think of down. All right, so an angle of elevation is formed between the ground and wherever the line of sight is. It's always going to be formed with the ground, like a kite. Think about like a kite that's tethered or stuck to the ground and it's forming a triangle. Or someone standing somewhere looking up. That's your angle of elevation. Angle of depression is a little different. Like angle of depression, they always talk about like a person standing and they're looking out into the horizon, whatever. They're looking down at an angle of whatever, okay? When we talk about angle of depression, this is what I want you guys to see here. The angle of depression is outside of the triangle that's formed. It's out here. So whenever you're given the angle of depression, because you're going to be given an angle and you have to put it in the triangle somewhere and then you got to put the sides. The angle of depression can be looked at two different ways. You can say that the angle of depression that they give you is same as the angle of elevation on the other side. Because two parallel lines that are cut by a transversal, alternate interior angles are congruent. Or what is formed right here? A right triangle. So if you're given the angle of depression and you want to know what this inside piece is, you could take 90 minus the angle of depression. And we're going to work more on this tomorrow, I promise. Either way you guys want to do it. If you want to draw your triangle the same way and always use the angle of elevation, you can. I'll show you how. Or if you want to use the angle of depression one time or elevation another, it's fine. Either way, you get the same answer if you put them in the right spot. So, here is where you guys need your calculators. When we are talking about these word problems, you guys are going to need a calculator because you're going to have to put this in using your trig functions. And if you're in the wrong mode, you'll quickly realize it once you do this problem. But every time we talk about a right triangle word problem, I always draw a big right triangle. Just start, you know it's a right triangle, so let's see what they tell us. They said a surveyor is standing 50 feet from the base of a large tree. All right, guys, where is the tree? Is the tree laying down on the ground? No. Is the tree leaning up against something? No. It's just a big tree. Okay, so I'm going to put my tree here. Do you have to draw a picture? Absolutely not. Do I think it's helpful? Yes. Okay, here's my tree. It says a surveyor is standing 50 feet from the base of a large tree. Some of you are like, I don't know where a surveyor is. Doesn't matter. You could say a dog is standing 50 feet from the base of the tree. Where does the 50 feet go? Why is it down here at the bottom? I agree. That's the base. This is the base of the tree, the bottom of the tree. So the person is standing here. You guys see the picture that we're talking about. You'll start to see words like how tall, how high, that sort of thing. They're talking about height. If they talk about how far away, what is the distance from here to there, they're talking about here, your x value. And then if you're talking about a ladder leaning on a house, a ramp, an escalator, if you're holding a kite and the string, how long is the string? They're talking about the hypotenuse. And again, you're going to start to see patterns and you're going to start seeing keywords that help you put stuff places. But that's the hardest part, is putting the stuff on the triangle correctly. And then the math behind it's not hard. Yeah, that's what we're going to work all day tomorrow on. So if we're talking about an angle of elevation, okay, where am I talking about? Am I talking about this angle here or this one down here? Because elevation, the person is standing looking what direction? Up. Right? So the angle of elevation is always going to be down here in the bottom corner. That's why I always draw my triangle in the exact same way. If it says elevation, I stick it right there. If it said depression, it would still be there. Angle of depression, if it was up here, is the same as the angle of elevation down there. You just have to put it in the right corner. Just because you see depression, don't automatically stick it there. You'd have to say 90 minus first. So now, let's look at what this question's actually asking. How tall is the tree? What are we looking for? The up and down or the leaning piece? We're looking for the up and down. So we have yet to answer the question. We just kind of set it up. So now I look and I say, okay, they gave me an angle. Cool. What is x in regards to that angle? Opposite, adjacent? Okay, it's opposite. What is 50? Adjacent. So what trig function uses opposite and adjacent? Tangent. So I'm going to say tangent of angle. Oh, they gave me an angle. It's tangent of 71.5 equals opposite over adjacent. And we set these problems up every single time. You're going to create. Okay, so we have this set up. It's just a fraction equals to a fraction, so we are going to cross multiply. So I'm just going to say x times 1. So I have x equals, and then I'm going to cross multiply here. You have 50 times the tangent of 71.5. In your calculator, hit 50 times tangent 71.5. Tell me what you got. 50 times the tangent. What'd you got? 149.4. Okay, so now you guys got to pay attention to whatever the directions are going to say in your test. Round to the nearest foot, round to the nearest tenth, something like that. And you have to have a unit. But this should make sense that the tree is about 149, say 149 feet, okay? If you're in the wrong mode, if some of you want to put your calculator into radians just to see, because first period we did this, I didn't tell them to put it in radians or degrees first. They came out with negative something. If you're in the wrong mode when you do trig stuff, it'll be really apparent because when you get the answer, it won't be super close to what it should be. So if you're talking about the height of a tree and you come out with negative 49, a bell or a whistle should go off in your brain. You go, oh, wait a second, something's wrong. I might be in the wrong mode, so you can check it. Just a thing to be aware of. Let's look at the next one. A large apartment building in New York City. Okay, first of all, I'm going to draw my big right triangle. And I'm going to put my theta here. All right, a large apartment building in New York City stands 135 feet tall. Am I talking about the X, the bottom, left to right? Am I talking about the Y, the up and down? If the building is 135 feet tall, here's my building, okay? This is 135 feet tall. Now, this question could ask a bunch of different things. It could say, how long would a ladder be if it was placed on the sidewalk to lean to the top of the building? What would we be looking for if it was looking for the length of the ladder? The hypotenuse. Think about what a ladder, if they had to build a ramp or something like that. But this question says that the angle of elevation, well, first of all, angle of elevation I know is going to go where? It's going to be in the bottom corner because the angle of elevation is in the bottom looking what direction? Up. Okay, so this is 37 degrees. It says that the angle of elevation is measured from the base of a fire hydrant on a sidewalk below. Guys, where is, yeah?
So if you said an angle of, was it decline?
Depression.
Depression, and it was like 60?
If they said angle, and we're going to do more of these tomorrow, but if they said an angle of depression, you would put the depression there. So if you wanted to use this angle up here, you would have to say 90 minus 37 and put that angle here. Or if they tell you that the angle of depression is here, you can always put it in the bottom corner down there. Always. All right. Whichever you want to do. And we're going to do those tomorrow. I didn't want to get real confusing today. Oh, I think when I erase, my words are there. Like, you can hear me, but then none of the writing is there, but whatever. All right, so it says a fire hydrant. Well, guys, think about, where is a fire hydrant? It's on the ground, right? A fire hydrant. So here's my little fire hydrant. Looks exactly like a fire hydrant, right? It says how far away is the fire hydrant from the base of the building. So what am I looking for? Am I looking for the bottom? Where is the base? It's down here. This is bottom side. So that's the hard part of these problems. The math behind it, you guys can all throw in your calculator. That's not the hard part. But understanding where all this stuff goes could be difficult. This is my angle that I'm referencing. So what is 135? It's the opposite side. What is x? The adjacent side. So what trig function am I using if I have opposite and adjacent? So I'm going to say tangent of an angle. Well, I have the angle they gave me. It's tangent of 37 equals opposite 135 over x. Well, this one's set up a little different. Last time the x was on top. Now the x is on the bottom. You do the exact same thing. We're going to cross multiply. So I have 135 equals x times the tangent of 37. The tangent of 37 is a number. It's just gross. So how do you get x by itself? Divide by tangent of 37. I would not do anything in your calculator until the very last step. Because if you do it in your calculator, if you hit tangent 37, and then you're going to divide, and then you have to hit something again, the more you round, the further and further away you get from your answer. So just wait till the very end. What is 135 divided by tan 37? 179 feet. All right, does that make sense? Yes, absolutely. If you got -2, probably not, right? So just check. A lot of these problems you can check and say, okay, this makes sense or this doesn't make sense. Sound good? All right.